Now let's understand that how we can access private class members inside a test class or inside a test method. And let me explain it to you with the help of an example. Remember that calculate class that we created earlier? I've created another class named as calculator, and inside this calculator class we have got some private methods as well as some private variables which we would like to access inside the test class in order to verify whether the functionality that we've implemented inside the calculator class is working fine or not. And in order to do that, we have got an annotation with the help of which we'll be able to access the private member variables and private methods of a class, and that annotation is at test visible, right? If you can just see over here, at test visible. With the help of this particular annotation, will be able to access the private members of a class inside a test class. After specifying this annotation, the other class or the other classes which are not test classes will not be able to access this result variable, which is a member variable of this calculator class, but any test class will be able to access this result variable as if it's a public variable, right? So when you specify at test visible before any variable, it becomes public, but only for the test classes or for the test methods. So that's basically what it means. And let's have a look at this class, this calculator one. And by the way, I have updated this calculator class a little bit in order to consider more scenarios and more in order to cover up more situations, to make testing or make its testing a little bit more difficult, but the code to be covering all of the scenarios. So yeah, that's what it is. This is a constructor which sets the value of result as 0. Then we have got add method, and inside add methods, let's have a look. It's not just adding x plus y, which is the value that we are getting inside the parameter of this add method. It's just not adding x plus y and then setting it into result. It is verifying whether x plus y will increase the range of an integer variable. So the range of integers in Apex is this 21474483647, and like let's say if I have given a number which is 21474833640, and like this is the first value that we have given and another value is 10. So adding both of these values will exceed the range of an integer. So in this particular situation, what we want is the result should become as 0. So this is what we want. So we are just verifying it over here. That's how we are just doing it. And at the end, we are returning the result. Or else, if this is the situation, just return 0. Okay, in the subtract, a lot of time what happens is people send different values into different parameters. Like let's say if 10 and 3 are given, then the answer should be 7, and if 3 and 10 are given, then also we want the answer to be 7. It should not be minus 7. So in this case, what we'll do is we'll first identify which one is greater than the other, and if the one which is greater than the other, then we'll subtract the smaller one from the bigger one, and then we'll return the result. So if 10 and 3 are given, it should return 7, and if 3 and 10 are given in an order 3 and 10 as a parameter, then also 7 should be given. So if x is greater than y, then x minus y, and if y is greater than x, then y minus x, and then at the end result. For multiply, it's going to be the same, of course, but again we can apply this. If the range of integer gets increased, we can apply that condition over here as well. Division, if y is equals to 0, the result should be 0, and I think we can add x is equals to 0 or y is equals to 0, right? So if either one of them are 0, if either one of them are 0, then the result should be 0, else it should be x and y. And now we have got another method which is random update result, right? So whenever we want to call a method which is called as random update result, what all this method does is it assigns a random value inside the result, and this is a private method that can be called anywhere from this calculator class. No other class will be able to call this particular method because it's a private method. In Apex, if you do not declare any access modifier before a method, it automatically sets it as private. And yeah, so result is equals to math.random. With the help of math.random method, we'll get the value. With the help of math.random method, we'll get a random value, and we'll just multiply it with an existing result, and then we'll just typecast it into an integer, and then we'll return a result. So it's a random method. It is doing nothing. It is just returning a random number, but it's a private method which can only be called from this calculator class. Now when we'll execute the test class for this calculator method, there will be two problems that we'll be facing. Number one, we'll not be able to test the private methods inside the class unless until they are called inside that particular class. So this random update method is not getting called from anywhere, not from the constructor, not from the add method, not from the subtract method, not from the multiply, not from the divide method. So this method will not be tested. That's number one problem. Number two, this will not be counted inside the code coverage, and what we want is that the code coverage should be as maximum as possible. So how can we call this method from a test class in order to make sure that this is returning the expected value, but any which way it is returning a random value? What we want in this particular situation is for the code coverage to be 100%. So in order to do that, what we'll do is we'll specify the annotation at test visible with this particular method, and this at test visible will basically what should I say? Yeah, we'll basically make this method available inside the test class so that we can call it from the test class, and yeah, we can get it into the test coverage. So that's basically what it means. So if you want any variable to be available inside the test class, if it is private, then specify at test visible, and if similarly for a method, if you want that private method to be accessible inside a test class or inside a test method, then just specify at test visible annotation with it, and with the help of that you will be able to access it in the test class, but not anywhere else, right? And when I say not anywhere else, it's but you will not be able to access that method or that variable inside any other class which is not a test class, right? Now let's have a look at the test class that we have created for this calculator method. Here it goes. So number one, at is test, again test calculator class, test random result. So we are creating a new we are creating a new object of the calculator class, and then we are accessing the value of result into A, and inside B we are just calling c.random update result, and we are just getting the value of B over here. So this method is just for the code coverage. This is not verifying any result or anything. Yeah, and even if you want to verify any result, as the method says, it should as the method says, it should return a 0 value. Why? Because whenever we create a new object, this constructor sets result as 0, and if 0 is multiplied by any math.random value, it will be 0 and will be set as a result, and this result will be returned. So I think we can just add system.assert equals 0, actual should be B. Yeah, that's it. Let's go to the next method, which is test.add. Now look over here. We have created a new object for it, and we are calling the add method, and we are specifying the value 4 and 5, and what value we are expecting? 9. So this 9 should be the answer, and if it is not coming up as this answer, then inside the description of the test failure, not working properly for positive value should be written, right? And over here we are testing it for both of the negative values. So again, as you can see, inside a single unit test, I am covering up as many situations or as many scenarios as I can for that particular functionality. So if I'm going to be passing -4 and -4, then R should get -8, and if it is working fine, then okay, otherwise let's leave it as it is. For 0 and -5, it should return -5, negative and 0 test. So we are doing different tests for a single method or for a single functionality inside a single unit test, inside a single unit test method. Now over here we have specified a number which is almost which is actually the upper limit of an integer variable, and if we're just going to add 1 to it, this 0 value should be returned, and if the code is not returning this particular value, then in that case this error should be displayed over there. So that's what it is. Similarly for subtraction, 10 plus 5, if we are giving 5 should be the value, -4 and -4, then it should become as 0, because we are subtracting both of these values, so one of the value will become positive and the addition will be 0. For subtracting 3 and 5, the answer should be 2 rather than -2, and for that we have already made a change inside the calculator class, and this is how the test is working. For multiply, 10 into 5 should be 50, -4 should be 16, 3 into -5 should be -15, and 3 into 0 should be 0. So all the different tests for multiply. Similarly for divide, 10 to 5 2, -4 1, 3 to 5 0, -4 4 -1, 15 -3 should be -5, 0 -4 should be 0, 2 divided by 0 should be 0, -4 0 should be 0. So yeah, these are different scenarios that we are covering up over here in this particular test. Now let's execute this particular test, and that's what it is. To again execute or to run this test, we'll just go to new run. We'll select the name of the class, test calculator. We'll just add test, add division, multiply, random result, and test sub. Let's see what this random result does first of all. Okay, this is the first one. I forgot. Select all and run. Success. Let's see whether all the values got satisfied or not. Okay, so it's a success for all the methods. Test add, test division, multiply, random result, test sum. For every one of them it's perfect. And as far as the coverage is concerned, let's have a look at the calculator classes coverage. It's 100%, as you can see. All the code is getting executed inside this calculator class, so the code coverage is 100%, and this is exactly what we wanted to do.